then most likely you might have just leave it blank. Okay, then during that particular question, then you can ask, hey, Miss Man, can you slow down a little because this question I really do not know how to do it. Then okay. But you don't expect me to slow down for every freaking question, okay? Next. So when you see a question like this, I will prefer that you underline. Okay, so 5 joules definitely is energy. By now you should know that joules is energy. Then 100 C means is a charge, okay? Then they ask you for EMF. EMF is V, so W equals to EV, which you either queen, so over here, E is actually EMF, okay? But it can also be just voltage, potential difference, okay? So over here, you must know what each of them represent, then you can substitute the correct thing in, okay? Then Q is charge. Rearrange it, make E the subject, is actually 500 over 100. Answer is 5. 5, please put a unit to it. Usually at the end of it, there should be a blank, then there's a unit there one. So you just have to put the 5 in there, okay? Next, it says I have 5 volts. So this is definitely EMF. Okay, then after that, supply to, sometimes values like this may happen, okay? 10 to the power minus 3, okay? But don't have to worry, okay? Just plunge everything into your calculator. The calculator will do the job for you, okay? So W, because you're supposed to find energy, E is actually your EMF, which is 5. Charge 10 to the power minus 3. Just copy as per normal. Answer should be 1, 2, 3. 0.05. Am I right? Those of you who did it. Okay. Those of you who didn't do it, don't bother copying the answer, no, really. Go home, do it again. Oh, I'm so sorry. Thank you. Oops. I repeat again, those of you who didn't do your work, please don't just copy. I'd rather you don't do and you just listen, go home, you attempt it again. Then if you want to double check the answer, just simply download this particular piece of notes that I uploaded on Google Classroom and check, see whether your answer and working is correct. No point copying, no, you're not a photocopier, no. You're a human. You need to sit for exams. Next, work done. So definitely over here, you're finding your W, then your energy over here. Okay, your voltage is here, energy unknown. Okay, so again, W, which you evil queen. W, evil queen, evil 2, queen 5. Okay, answer 10 joules. Question? No, gone. Next, over here, PD. 240 volts, 2C, you are supposed to find energy. So again, which you either queen. W is unknown, E is 240 because you see it could be a PD, take note, okay? It need not be a EMF, okay? So queen is 2. Answer 480 joules. Next, 0.5 is your ampere. Then you realize 4 volts is written there. They want to find energy. To find energy over here, wait again, sorry, 10 seconds. To find energy, the only formula you have in electricity to find energy is which you either quit. Okay, so usually this is what I will do. I will write down the formula that enable me to find my answers. Okay, then I will have to double check to see whether do I have all the information there. That means I will basically need my E. Do I have my E? Yes, this is my E, EMF, okay? It can also be PD, okay? This is my E, so this is my 4. Then I realize, don't have Q, leh. Then what should I do, okay? I know that Q is actually IT, right? Of course, you can do it separately. If you don't wish to do it like that, you can do it separately. Q equals IT, and you put in your I, which is like 0.5. Your T is 10 seconds. You will get like 5C. And then you put it as 5. Okay? What is the benefit of doing it separately? Just in case you accidentally do not know how to rearrange your algebraic equation and end up doing the wrong thing. Okay, then at least maybe Q equals IT, they can give you 1 mark. Alright, but the benefit of doing separately is like that lah. In case your final is wrong, at least they can give you some working mark. Okay, so this will be 20 joules. I'm not saying that you cannot do together. You can do it together. Okay, just like what I written over here, 4 bracket IT, you can. But the thing is, you must make sure that it's correct. Okay? If not, if you are very kiasu or you scared, then I would suggest you do it separately, 1 by 1 like that. Okay, next. Which circuit correctly measure the current? Current must be ammeter and ammeter must be in series. So you must supposed to go and find out your ammeter must be series, ammeter must be series, ammeter must be series. Then you see which is the one that actually passes through the lamp. It must be the lamp. So this one pass through the lamp, the ammeter pass through the lamp, ammeter pass through the lamp. Okay? This is wrong. Ammeter cannot be placed across. It must be placed in series. Then next, your PD across. You see, when you see the word across, it means that you must put it as a second level of basement, okay? So across, across, across. So all of them are across except your C lah. C is series already. So this is totally wrong already, okay? So this is like wrong. Okay, so across who? Across again must be a lamp. This is not lamp. Okay, this has too much. So only answer is B. Okay. Next, which cells will lose energy the fastest? Cell? Oh yeah. Okay, the XXX are all our wires. Okay, just imagine them as bulbs. Okay, light bulbs. Okay, so if you have a lot, which is the one that will make it lose energy the fastest? Is the one that is connected. All the bulbs and whatsoever bulbs are connected all in series. This is the worst. It will consume the most energy. Okay, right? So, because everyone is drawing everything from that fella, okay? So, which is the one? So, if you do not know, okay, you just have to check. This is just one definitely out lah, right? So, you have 1, 2. Okay, this is parallel, no. Wait a minute. Lose energy the fastest. Oh, wait. I read wrongly. In parallel there. Okay, why? Because this particular light bulb over here or wire is taking in so much energy from the battery, and this one over here is also taking the same amount of energy from the battery. So you take $2, I take $2, you take $2, I take $2. Okay, that's the reason why this one will consume the fastest. Okay, then let's check this one. This one has something that C has. Okay, this is exactly the same as C, but on top of it, what happens? There is also another series. So this will be the one that consumes the fastest. Okay, during exam, this kind of question will not happen. They will most likely put in the same number of light bulbs. Putting in all different variation. They can put one that is like that, like that, like that. The other one is like that, like that, and like that. Then the other one is maybe like that, then like this. Then the other one is maybe like this. So 4 different variations, all got 3 light bulbs. Then which one will consume the most? This one. Okay? Parallel. Right? Next, this one, last one. X and Y are identical lengths. So in the first place, X and Y are in series. Okay, what happened to the brightness of Y when a third Z is connected? Okay, this one you may have a little bit of difficulty. Why? Because usually this kind of question needs to do a bit of calculation, but can you do it by common sense way? Maybe. Okay, maybe. Alright, so usually, I do not know, have you learned before resistance formula? No, right? R plus R plus R, 1 over R. Okay, so this one we KIV first, can? I will show you using the formula, okay? So we KIV first. This kind of question will not come out, don't worry, okay? Next chapter, DC circuit, we talked about it already. Then I will bring, don't worry, I'll bring this whole entire page to DC, okay? So you will not miss anything. Okay, so you don't have to bring these particular notes when we are doing the next chapter. Okay, so we skip all the way now. Okay, let's do this. Right. Now, 2 ampere, PD, 6 volts, find resistance. V equals to Ri. R is the unknown, so we leave it there. I, 2, V, 6. So R equals to 6 over 2, answer 3 ohm. Can you please help me to write down 3.0 ohm? Why must be 0.0? You see all your values over here are all in 1 dp, okay? So we follow suit. But during exam, you put 3 ohm is fine, okay? It's fine. They are not too particular with N-level student, okay? So don't worry. Next, current, do not know what is it, but I know my resistance is 10, PD is 20. So again, V equals to Ri. V20, don't talk, R is 10, I unknown. So make I the subject is 20 over 10. So I over here will be 2. You must always make sure that your unknown is always on the left. So even if I can put it this way, no problem. This one over here is okay because I will always put my final answer with the unknown in front. Okay? Question so far? Next. Oh, done. Yay. Okay. This is the last part. I want to clear this the other time, but I think you guys were a bit not cooperative. You're tired. Okay. So let's do this. Okay. So over here we are looking at wires. Wires comes in all shapes and sizes. Okay. So we have wires that are really long, like this. We can have wires that are really short. Okay. And we can also have wire that's really fat. Okay. We can also have wires that are skinnier. You see the thickness of it? This is only like that, but this is longer. Okay? Lengthwise is also different. So I need you guys to imagine you are trying. Remember the previous time round I was talking about the indoor playground, but it seems like none of you appreciate that particular analogy. Okay, so let's do the train method, okay? So imagine if your train, if these are all the current, these are all the charges. These are all your electrons in the wire. Okay, so imagine now you have a very long wire and this is the amount of charges inside the wire and you are supposed to move. What happened? Let's say you are one of the people in there and you want to move from one end of the train to another. What happened? You will most likely be brushing past every single one of them, right? Hey, excuse me. Then you brush past some sweaty ones, some not very nice one, okay? So you brush past everybody. And you will feel that you have a lot of resistance. Why? Because some people just refuse to budge. You cannot move. Resistance. Okay? And imagine you literally have to move from one end of the train to the other end. You will at least take 15 minutes maybe because some people just refuse to move or cannot even move because too much charges already. Compared to another one, bigger, thicker, more spacious. It's like macam you buy the business class ticket like that, okay? And there's no one. You can easily just get through the train from one end to another because next moment is so short. It's like your private cabin. Okay? You understand? So which is easier to move? Of course, this is the one, right? It's more spacious, shorter. By the time you reach the other end, you can run like 10 times up and down to one end to another, one end to another. As compared to this one, okay? Not so easy. So what does it mean? It means to say that when your wire is actually pretty long and thin, this will contribute to the highest resistance. Long is one thing, no. Long is already very high resistance already. Thin lagi worse, no, it's like combo charge, no. 2 times, okay? Very, very high resistance. Which is the lowest resistance is where something is short and fat. Okay? This one is the lowest resistance you can ever have. Can you please stop writing messages to each other? Okay? The longer the wire, the higher the resistance, the smaller the cross-sectional area. That means very thin, very thin. Okay, this is thin. Then again, the resistance will also be high. Okay? The third thing that a wire is relying on for resistance is the resistivity. This is something that usually we are not too particular. Okay? Usually in the question we will say that, oh, these 2 wires are the same material. The minute I say that these 2 wires are the same material, this rho, this resistivity, you can basically cancel out from the formula already. Okay? Because resistance is dependent on 3 things. First, the material of the wire. Whether the wire is made of copper, silver, gold, nickel. Okay? Different material have different resistivity. Okay? The one that has one of the highest is nickel. The one that has the lowest is gold. That's the reason why those people who play sound system, I don't know whether your parents play sound system, it's like that one dedicated room full of sound system, then go in, must listen to what? Very nice music, then the sound is super clear kind. Do you know the cables that runs all this sound system in that particular room is made of gold? That's the reason why people who play sound system can mount to like 5 digits. One set of cables can easily be $100+, because you are literally buying gold. Some cannot afford to buy silver, it's as good, okay? But the copper wire that we have over here, you can still use it to run, but of course the sound will not be as great, okay? Because more resistant. It's like preventing the current from moving, okay? See L, the capital L over there is your length, okay? Your A is your cross-sectional area. So the minute I say, okay, this first wire has this much of resistance, made of copper, this length, this area. The second wire of the same material. The minute you see the word of the same material, you can simply remove this from the equation. Okay, so if they say the second wire is of the same material, you can simply remove this from the equation and you just compare your L and A. Okay, later you will see I think one question on that. Okay. Okay, question so far. So this is a lot of visualization. This part over here about how length and cross-sectional area, that means the thickness of the wire, actually affects resistance. When you have more resistance, means the current cannot flow so easily. Okay, remember this, this one must remember. So if you have very high resistance, what happens? The current flow will slow down. Definitely will slow down. But if, of course, your resistance is lower, just like the fat and short wire, then of course current can flow past very quickly. Have you encountered this before? When you actually, do you know the wire that's provided by Apple or whichever Samsung, whatever phone that you're using, the wire that they provide to you is always a 1 meter long only. Because they believe that this is the most optimum. It's long enough for you to at least use it at your sofa when you are charging it. Second, it is considered quite fast charging, okay? But some of you, because your power point is like freaking far like this, and you want to buy like a 2-3 meter long wire just to charge your phone while using, and you want to sit here. Then as you are using, you will think, so funny when I on the switch, how come instead of the battery percentage going up, it's going down instead? Because you are using much more electricity as compared to how the phone is being charged. Why? Because the length of the wire is super duper long. Long wire, remember we said just now, long wire, high resistance. So the current doesn't flow as quickly as you think it should. And because of that, you are still playing some games on your phone, but you are charging. But you are losing energy much more than how you gain it because of the high resistance. That's the reason why those people who drive and still wish to charge their phone in the car, do you know that there are some charging wires so cute, it's only this long? Right? So it's sufficient enough for you to plug your phone and plug into the USB cable in your car, as in USB port in your car, just for charging purpose. Because you cannot use your phone while driving, right? So you charge and it's very quick. 10 minutes drive can easily up a 10% already, very quickly. Because short wire, lesser resistance. You understand now? You understand? Sometimes if you use the wrong wire to charge and somehow like super long wire, you realize that, how come my 3-pin plug are so hot? Because lots of resistance, okay, coming in. Okay, so over here, remember, lower length, shorter length, lesser resistance, longer length, higher resistance, smaller cross-sectional area, high resistance, bigger cross-sectional area, lower resistance. Okay? Let's do part 1 together, then the other 2 you leave it as homework. Okay, so these 2 are homework for 5th Feb. Okay? So let's do the first one. So now they say this is a nichrome wire. So we all know that this is the material, nichrome. Okay? Then it is 1 meter long. So this is my L. Then it has a resistance of 8 ohm. Okay? So I'm supposed to find the resistance of this wire. That means I'm supposed to find my R. Okay? If now the length is 3 meters long of the same diameter, that means my cross-sectional area is the same. So using the formula R equals to rho L, I like my L like this, okay, because I don't know, I just like the liters L. Okay, up to you what L you want to write, okay, it's fine. Okay, over A. So because it is of the same material over here, I can omit my rho. I don't need my rho anymore. So now I'm just comparing R equals to L over A. So what is my L? My L is 1. Okay, and my resistance is 8. So my first wire will be R equals to rho L, no rho already, okay? So my R would be 8 ohm, 1 meter long with a A. Then make A, I got no space, but right, you're not supposed to use the arrow, okay? I'm just trying to separate the working out. Making A the subject, A would be 1 over 8. Okay, don't worry, you can leave it like this, okay? It's fine, alright? Okay? Then after that, using the same A over here, because of the same diameter, I repeat the formula again, rho L over A. But now, what happened is, I'm supposed to find the resistance, my length is 3 meters, and my A, because it says same diameter, right? So it's 1 over 8. So press the calculator, 8, 16, 24. 24 ohms. You see that? So you totally can omit your resistivity, which is the P look-alike thingy. Then you just calculate from there, like math. Okay? So you go and try part 2 and part 3, okay? Can? Okay, good. Okay, I will pause this thing.